What just happened has left the entire tech industry stunned. Huawei has officially confirmed the development of a homegrown EUV, extreme ultraviolet, lithography system, a breakthrough that could redefine the global semiconductor landscape. For years, the semiconductor world has been dominated by the West. Giants like TSMC and Intel have relied heavily on EUV technology, widely considered the holy grail of chipmaking, to produce the most advanced processors. Meanwhile, China has remained shut out of this elite circle. US-led sanctions have blocked Chinese access to EUV machines, especially those built by Dutch firm ASML, the global leader in this field. Analysts predicted that it would take China's at least a decade, possibly 15 years, to close the gap. But recent developments suggest China is moving far faster. Huawei is already testing an in-house EUV system at its Dongguan facility. Trial production is expected to begin in Q3 of 2025, with full-scale mass production targeted for 2026. This development is not based on speculation. Credible sources have confirmed it. It's all part of Huawei's audacious plan to manufacture 3nm chips, a level of advancement once thought unreachable under current sanctions. The roots of this push go back to 2019 when the US imposed sweeping sanctions on Huawei, cutting off access to American technology and advanced chip-making tools. ASML, under political pressure, halted EUV machine shipments to China. Huawei's chip-making partner, SMIC, Semiconductor Manufacturing International Corporation, was left with only DUV, deep ultraviolet tools, which max out at 7nm. At that moment, China's semiconductor ambitions appeared to hit a wall. But instead of retreating, Huawei and China doubled down. Massive investments poured into R&D. National efforts were coordinated. Talent was recruited. And from scratch, they began developing an entire EUV ecosystem. What sets Huawei's system apart is its use of laser-induced discharge plasma, LDP, a new type of EUV light source that differs significantly from ASML's laser-produced plasma, LPP, approach. LDP involves vaporizing tin between electrodes and hitting it with a high-voltage discharge, generating plasma that emits EUV light at the necessary 13.5nm wavelength. It's a smaller, simpler, and cheaper alternative to ASML's $350 million EUV machines. The system under testing in Dongguan is reportedly built by a Chinese firm, likely SMEE, Shanghai Microelectronics Equipment, which filed a patent for this exact technology in 2023. If successful, Huawei and SMIC could begin mass-producing 3nm chips by 2026, breaking through the tech blockade. This move is part of a larger, coordinated national push. Researchers from Harbin have also announced progress on their own EUV light source, matching that crucial 13.5nm wavelength. China is pouring resources into this effort, accelerating faster than most predicted. Why 3nm matters is simple. Smaller chips allow for significantly higher performance, better energy efficiency, and the ability to run advanced AI models directly on devices. This advancement would revolutionize smartphones, autonomous vehicles, and even quantum computing. The West's current lead in 3nm chips underpins NVIDIA's AI strength and Apple's smartphone dominance. If China masters 3nm, it could shift the entire balance of power. If Huawei and SMIC succeed, ASML's market dominance could be seriously threatened. A lower-cost Chinese EUV alternative could undercut the West's expensive machines and flood the global market. The irony is stark. U.S. sanctions, meant to suppress China's tech rise, may have sparked a more determined, self-reliant Chinese semiconductor movement. Even NVIDIA has warned investors about Huawei's progress in AI chips. Huawei's founder told President Xi Jinping earlier this year that chip shortages are easing, another sign that the strategy is bearing fruit. However, challenges remain. Huawei's LDP-based EUV is promising but unproven. Technical glitches during trials could delay production. Even if it works, yields might not match the refined processes of TSMC and Intel. It took ASML 2 decades to perfect its EUV ecosystem, including optics, mirrors, software, and service infrastructure. The West isn't panicking yet, but it's watching closely. What's unfolding is not just a technological race. It's a battle for sovereignty. China no longer wants to rely on foreign technology. Huawei's new R&D campus in Shanghai is hiring top-tier talent to build an indigenous lithography infrastructure from the ground up. Xi Jinping has declared tech self-reliance a national mission. This EUV breakthrough shows that it's more than just rhetoric. ASML's CEO said late last year that China was still 10 to 15 years behind without EUV. That gap is closing rapidly. SMIC has already surprised the world with its 7nm chip output for Huawei's AI processors. If 3nm becomes reality by 2026, that timeline will be history. Still, building a full EUV supply chain, from optics to software, is a monumental task. But China is betting big. Huawei's EUV test is confirmed. The 3nm plan is underway. The global chip game is entering a new phase. This isn't a story of underdogs, it's a story of a giant reinventing itself. By late 2025, the world will know whether this machine is the breakthrough that redefines the future of semiconductors. Meanwhile, Huawei is also setting the stage for a wireless revolution. A new space-based communication technology, an aerospace version of Huawei's NearLink module, promises to radically improve wireless connectivity. Bluetooth has long been the standard, despite its flaws: sluggish speeds, poor range, and battery drain. Huawei's NearLink could change all that. It offers faster pairing, lower latency, better power efficiency, and far more stable connections. We've all struggled with failed Bluetooth pairings, or dropped connections during a call or stream. NearLink aims to eliminate these issues, delivering seamless device integration and dependable communication, on Earth and even in space. As China accelerates its push for tech independence, from semiconductors to wireless communication, the world is witnessing a dramatic shift. The rules are changing, and Huawei is at the center of it all.